Can we start, sir, or are we expecting?
Yeah, we can start. Yeah.
Um, Hello, everyone. Welcome to the APPCAIR seminar series. So today is the fourth talk by Professor Navneet Goyal. He would be talking on opportunities and challenges within Edge AI. So thank you, sir, for participating.
Yeah.
Please go ahead.
Yeah. Thank you, Aditya. And let me just begin by sharing my screen. I hope it's coming.
Not yet, at
Not
least
yet.
on my side.
Okay. Just hold on.
Yeah, now I can see.
Now it's there.
Yes.
Okay. So can you see the first slide? I'll
Yes,
put
I
it
can
in
see.
the presentation mode. All
Yes.
right. So today I'll be talking about Edge AI opportunities and challenges. So this Edge AI is fast catching up, and so there's a technology where we want to basically do all the AI related computations as close as possible to the source of the data, right? So and then there are a lot of there is a lot of motivation for doing this. So I'll be talking about all of that, and I'll try to keep it at a high level, but wherever required, we can discuss the technical aspects involved in this. And this is one area that we are trying to get into. So I thought it would be the best thing to do is to give a talk on this, right? So please excuse me if there are like some glitches while I present, because I'm also learning this topic. So anyway, so we'll begin with what is Edge AI and motivation for Edge AI. And so there is also a comparison that we can actually make with federated learning. And there are a lot of similarities as well as differences. And like when we talk about the future of Edge AI, then we will bring these two concepts together and then look at a few things, where a few solutions where we need to actually use both the technologies. Then we have model compression techniques. So this is one of the techniques that that are used in Edge AI, and there are quite a few standard techniques which were used otherwise also, but they are becoming more prominent because of Edge AI. And then, of course, there are privacy and security concerns as you move the data, maybe not too far from the source, but actually you're moving the data away from the source. So privacy and security concerns would automatically come in. And then towards the end, I'll talk about future of Edge AI, so where we are heading, and yeah. So some numbers to begin with. So this should tell us that, yes, there is a lot of interest in Edge AI, and we should all be looking at this as a solution. uh, for many applications. So you can see that by 2029, the edge AI market size would be around $107.5 billion. So that's quite a quite a bit of money there, and exhibiting a CAGR of 31.7. So that is also very encouraging. So let me begin by talking about what is Edge AI and what kind of possibilities it opens up. And I'll also tell you, right, what is driving this interest in Edge AI over the last few years. So that is also what we'll be discussing. So Edge AI is basically the deployment of AI applications in devices throughout the physical world. So when we say devices, so these devices are mainly the ones which are generating data. Not all the time, not in all the cases, but in most cases it is like that. So one of the things, one of the devices that you can think of is a sensor, right, or a collection of sensors. So all these sensors are capturing data. Okay, so how do I take AI to these devices? So it's called Edge AI because the computation, the AI computation is done near the user. I'm not saying at the user, and at the edge of the network, close to where the data is located. So there are two things that are important here. One is near the user or near the device, which is generating the data. Okay, so that is important. And another term that is important is that we are doing it at the edge of the network. So we also need to understand what this means. And since the internet has global reach, the edge of the network can connote any location. It could be any location like a retail store, a factory, or hospital, or traffic lights, autonomous machines, vehicles, and phones. It could be anywhere, right? So that is what opens up lots of applications in Industry 4.0. There is something called as industrial IoT, hospital, healthcare, retail, uh, uh, autonomous vehicles and traffics, and of course phones. So I mean, you can see everything can get benefited from this technology. So by bringing AI closer to sensor or data source, the goal is to reduce the amount of data communication. So that's the first objective. And if you are familiar with federated learning, so you will see that some of the objectives are the same, right? So reduce the amount of data communication. So in federated learning also, we don't communicate any data, but here we need to communicate data to a nearby edge device. So we'll also see what are these edge devices in a minute. So the second is to lower the global energy consumption of the digital infrastructure. So that is another very important thing. So you must be familiar with energy aware computations, and so energy is required for all purposes, whether you are capturing data or you're analyzing data or you're communicating data. So all these things have to, the energy consumption in all these three aspects of data needs to be minimized. And of course, the main objective is to reduce latency for decision making. And you'll see that Edge AI is becoming very popular in real-time applications. So integrating AI near to sensor needs, and please feel free to stop me at any time whenever you have a question. Otherwise, it becomes really monotonous. So integrating AI into near to the sensor needs to specifically work at different scales. So one, we need to work at the algorithm or the training part of it. Then compression, model compression, I hinted at quantization of the network. So these are another things, and hardware, software co-design. So these are the three things. So we need to explore neural architecture that reduce parameter or computations. So compressed networks, as we call them. So there are different techniques which we'll be looking at later. Okay. So what is driving the demand for AI? So there are three factors that are governing this. First is advances in technology like AI. So there have been breathtaking advances in AI in the last decade or so, and exponential growth in IoT devices. So the number of devices connected are increasing. That number is increasing, and the power of edge computing. So now, in the last 4 or 5 years, we have been focusing on edge computing a lot, and edge AI basically uses the power of edge computing. And couple this with the rising demand for autonomous vehicles, surveillance cameras, and robotics. So you want all of them to pass on their data to the edge devices, right? So that you can do, or you can run your AI algorithms on that. And it is not always possible to have the kind of power, the compute power, the storage power, the memory on these devices to be able to do the complete AI. Uh, and increase sensing capabilities, including satellite and drone-based sensing. So in the last few years, again, the sensing capabilities have gone up, right? So we can actually sense almost anything that is happening around us. So this is again the advances in the sensing technology or the sensor technology is generating a lot of data and demand, of course, for analyzing this data in real time. And organizations from every industry are looking to increase automation to improve processes, efficiency, and safety. So all these things like the technological advances and the demand for a lot of these things that I just discussed uh, has pushed Edge AI. And according to me, one critical observation that is driving Edge AI is that not all end devices currently connected or to be connected in the future will have the required hardware, energy, and communication capabilities to be able to perform compute-intensive AI tasks. So because we are looking at an order of trillions of devices, IoT devices in the near future. So it is not possible to have all these capabilities on all of those trillion devices. So you have to look at uh, solutions. So this is where Edge AI comes in. So where to offload AI tasks? So this is the main question that we need to ask. And it is not that these devices will not, so when I say devices, basically I mean the ones that are generating the data, okay, or the data sources. So where to offload these tasks? So for this, we need to look at what are the options. So options are not many, like whether you do it on the cloud, you send all your data to the cloud, or you do it in the end devices. So as I said, end devices may not have those capabilities, hardware capabilities, to be able to do that. So now we are looking at a solution that is somewhere in between. So we are now looking at somewhere in between. We are not interested in cloud. We are not able to do everything in the end devices. So we need to be placed somewhere in between them. And this is where the edge devices come into picture. So, okay. So, okay, this I'll come to later. Yeah. So the edge. So you can see on the left are the IoT devices, and in the middle are the edge devices, which could be typically a switch or a roadside infrastructure in case of autonomous vehicles, or it could be a wireless or access point, a wireless access point. It could be anything. So you can see here that the edge sits in between the data generators on the left and the cloud to the right. So now this is my complete environment, and I need to do a lot of AI stuff with minimum latency. So what do I do? Now these devices that are there on the left do not have the capabilities to do all the things that I want them to do. So I go to the nearest facility where I can get these things done. So it is not that everything gets done at the edge. So what we do basically is that based on the capabilities of these devices, we do some kind of data processing at the device level itself. So say for example, I have enough memory to do the pre-processing of data. So what I do is I do the pre-processing at the IoT devices and then send the pre-processed data to the edge. So the idea is that I do as much as computations on the device, okay, and then pass it on to the next level. So this is again the same thing, I mean, with some more annotations. So you can see here the kind of network that you have between the edge, which is at the center. On the left is the cloud, and on the right are the devices. So you can see many a times we use wireless communication between these devices and the edge infrastructure. So, and you can see there is another thing that is mentioned on the right, that is cross-device federated learning. So federated learning, so if you do everything on the device, right, train your models and do the model communication to the FL server, so then you are doing federated learning. But here, some part of those computations, like I said, pre-processing probably be done at the device level, but we do the remaining part of it at the edge, which are more sophisticated, which probably have more space in terms of the size of the device, and better hardware and better software. So related technologies, as I said, are IoT, 5G and beyond. We now know that 6G communications are also being talked about, and of course, AI ML, so this I can skip. Now, the main thing that is observed, so this is a data that is being quoted in one of, I forgot to put the reference. So it says that data volume explodes with AI, 5G, and IoT advancements in these three technologies, but only 25% of usable data reach a data center. And the possible reason for this could be the prohibitive communication costs. So communication, and so we are not able to communicate all the data in reasonable amount of time to the cloud. So only 25% of usable data which can be analyzed reach a data center. So 75% of data must be analyzed on site immediately if your requirement is real time. So this is the statistics that is very important. So you can see that a lot of data has to be analyzed at the site only. So, but the site has very limited capacity. So the only solution or the way forward is edge. So this I can skip. This is just a quick comparison between on-device computing and cloud computing. So, I mean, there have been, like you must have looked at performance advances performance gains when we switched from, say, Hadoop to, say, Spark. So, right, so those similar kind of gains we are expecting here as well. So on-device versus cloud computing. So on-device computing, low latency, no network bottleneck, degraded service quality, limited computing power, right? So DNN models need to be compressed, pruned, or quantized. So these are three techniques, two techniques basically for compression, pruning, and quantization. And we don't want to we don't want to compromise on the performance of the DNNs in terms of accuracies. And cloud computing provides high service quality, high bandwidth consumption, data streaming, and high and uncertain latency. And again, this is a picture which tells you about the latency part of it. So if you look at edge mist, so these are different terms that are being coined in the literature. So there's something called as edge cloud now, edge fog, edge mist. So basically when you look at edge mist, these are basically the devices. So these are trillions of devices that we are looking at. And let me tell you that the most killing application would be the surveillance cam application based on surveillance cam. So what you want to do with surveillance cam. So that is going to be one of the killer applications for edge. So I'm not, so you can see the latency is well understood. So I'm not going to, so you can see the tree, how it kind of expands as we go down the tree. So the fan out is very large, right? So hundreds of sites in terms of cloud, then thousands of sites in terms of edge clouds and so on. And use cases of Edge AI include connected vehicles, so real-time monitoring, collective perception of a situation. Then you have smart factories, assembly lines, diagnostics for healthcare, so real-time diagnostics. So all of these things can be possible with Edge AI. So now let me come to model compression. So this is one technique where we want to compress the model. So mainly looking at neural networks, deep neural networks or deep learning models. Uh, so model compression broadly reduces two things in the model. One is the size, and the second is the latency part of it. So latency in terms of predicting a label or doing some regression. So size reduction, reducing model parameters, thereby reducing RAM requirements in execution and storage requirements in memory, and latency reduction in terms of the time for prediction, and most compression techniques would reduce both. Okay, so not just the size, but also the latency. So as size reduces, the latency automatically reduces. And these are some of the techniques that we have for model compression pruning. Like if you have done some kind of decision tree network or decision tree classifiers, so there also we do pruning. In similar ways, we do pruning here. Either we do a pre-pruning, that is, we don't allow the tree to grow too much, or first we allow it to grow and then prune it. So that is called as post-pruning. So here also we start off with a very simple network, and so that is pre-pruning, that we don't allow the network to be very complicated. And the other way is that you have a complicated network and you prune it to lower this thing, a simpler model by removing some of the nodes or links. So I'll show you that. Then knowledge distillation. So this is basically about transfer learning, a kind of a transfer learning model in an edge AI setting, and low matrix factorization. So as you know, matrix communication is one of the major things that we do in federated learning. So how do we do that when the matrix is very large? So this comes under low matrix factorization. So this is an example of pruning. So before pruning and then pruning, you can do the pruning of neurons, pruning of connections. Okay, so on what basis you would do that? So there are many techniques that have been proposed in the literature. So in the interest of time, I'll not go there, but yeah. So now you look at this picture. So this basically gives you the evolving AI ML perspective of Edge AI. So you can see here, if I move from left to right, the amount of data that is getting decreased, but the kind of intelligence you can incorporate increases. right? So if I were to run a very simple like perceptron model, maybe at the mobile device, I could do that, but I'll not be able to fit in or run a deep neural network on the mobile device. So the challenge here is that where we want to be. So which side? So right now we are showing you just three hops, right? Or three options, right? Okay, so one, you could be there at the mobile device, or you could be there at the cloud server or at the edge server. Now the things that are evolving is that can we have something in between these two layers, like between the mobile device and the edge servers, or something in between the edge servers and the cloud servers? So how the whole framework will take shape, it'll depend primarily on the application that you have at hand. So these are some fixed solutions. So Edge AI is now being incorporated into this PyTorch, and you can do Edge AI there. And some other frameworks, programming frameworks, allow you to do Edge AI. So as far as future AI of Edge AI is concerned, so this probably is my last slide. So it would require you to uh, collaborate between Edge AI and federated learning. So federated learning is one extreme, and on the other extreme, you have this cloud computing, right? Or you use those cloud servers. And in between, right now, we have Edge AI, and then there are some talks about what we call as future clouds, so which are not necessarily uh, a very big cloud, but some very small clouds which are placed between the cloud and the edge AI. So as I said, this whole scenario is very fluid right now, and we don't know where we are going to end up with. So this is something that is going to happen. So you want to do a kind of a collective, or you want to bring together edge AI and federated learning, because you'll have a mix of devices as well. Some devices would be capable of doing few things, and some devices will not be. So how do you segregate them and what you make them to do as part of your application? So these are some open-ended questions that we have. And to unlock the true potential of future networks like 5G and beyond, like 6G, as I said, is already in the works. Various technologies, both at hardware and software levels, need to coexist and cooperate. So this is what is that. So with that, I'll close. I hope I'm done in time. So please feel free if you have any questions.
Yeah, thank you, Professor Navneet. Any questions? Uh, Pavan, we can't hear you.
Yeah. Hello, sir.
Yeah, hi.
Thank you for the talk. Sir, I was just wondering, like, if we compare with the cloud
Yeah,
to our edge computing, the connectivity issue and the security will
yeah,
be more vulnerable, like security issue.
yes. So that's what I mean when we started talking about federated learning. So that was the main idea, that how do you reduce the communication costs, as well as how do you uh, address the privacy concerns. Okay, and safety concerns are also there. Like, so all that
Yeah.
I didn't talk about much in today's
Yeah.
talk, right? Because I just wanted to first give an overview.
Okay.
So when you are doing things at the cloud, so all the three things are are there. I mean, these issues are there: privacy concerns, safety concerns, and communication costs. So communication sometimes becomes a bottleneck. That's why I said that a lot of data you is being generated, but not all that data reaches the cloud servers.
Uh, yeah, I have a question. So
Yeah,
most of these AI techniques, they are
right.
at the heart of it statistical, which means that no matter how hard you try, sometimes they just give wrong answers. So
Yeah.
for such a system to be distributed or communicated across small devices, do you
Uh-huh.
think that increases the robustness or reduces the robustness?
So robustness, in say, if you just look at, so it is more robust than, of course, the cloud computing model. Okay.
Okay.
So suppose your organization is using some cloud service, and for some reason something goes wrong, right? So it is a kind of a single point of failure. But here in edge devices, so there's a lot of redundancy that automatically gets built.
Okay.
Yeah. So
So
you have multiple devices and multiple edge devices, which double up for computations and a lot of other things. So there's no single point of failure.
okay. So something like the ensembling idea.
Yeah, yeah, something like
Okay.
that. Yeah.
Okay.
And even in federated learning also, like if you look at it, it is a client server model, and it is still a single point failure model. But what we do is that now there are models where you have hierarchical federated learning, where you don't do all the computations at the server. So that also brings in fault tolerance.
Okay. Okay. Yeah. It was an interesting presentation. Any other questions? Okay, let's thank you, Professor Navneet, for again for presenting the nice talk.
Yeah, thank you.
Uh,
Thank you
yeah,
so much. And probably I'll plan a more technical thing. This was the first kind of talk as I see it. And next we can talk more about those model compression techniques and hardware software co-design things that are there. Although I'm not an expert on hardware software co-design, but that if somebody can take it up, that would be very interesting.
yes, that would be interesting. Okay. So
Okay.
thanks everyone for being here. So let's meet again next week. I guess same time, 3:30.
Yeah.
Thanks.
Yeah. Yeah. Thank you everyone for attending. Thank you.
Thank you.